Alright, well this video is for the assignment on compound inequalities for Math 95. And these compound inequalities have to do with these, what are sometimes called logical connectors, and or. Okay? So, with some problems, let's see, if we'll just take problem 2 from the assignment here, -2 less than or equal to x minus 2 less than or equal to 2. And for or, I'll take number 12. We've got a minus 4 less than or equal to -2, or a minus 4 greater than or equal to 2. Okay. So the basic ideas about and or have to do with the fact that here, this statement, x minus 2, has to satisfy two things. Both x minus 2 less than 2, and at the same time, x minus 2 greater than or equal to -2. So there's another way to write this statement. Okay? Most times people write it all in a line like this, and if you write something all together like this, it means and. Okay? Over here with or, what we're saying is one of these two things needs to be true. If neither of them are true, then the whole thing will be false. Okay? And those answers won't be included. Okay? Those answers won't satisfy one of these two statements. I think in this situation, it's not possible for a number to satisfy both of these statements. And we'll see why in a minute. And let's see here. Or we could have a number that satisfies neither of these statements. Well, let's see what happens. Let's see here. First, we'll solve number 12. So first thing we want to do is we want to solve this just like a regular inequality. We get a less than or equal to +2, and over here, a greater than or equal to 6. And the or statement is important. Okay, so there's our answer, a less than or equal to 2, or a greater than or equal to 6. And if we put this on a number line, what you'll see is the standard way that these or statements typically come out, which is that you'll see things going off in two opposite directions. So less than or equal to +2 would look like this. And then greater than or equal to 6 goes off in this direction. Okay? And this is what I was just saying a minute ago. This is typical of what you'll see from the or statements, as they go off in two opposite directions. Okay? These numbers in the middle between 2 and 6 don't satisfy either one of these, and so those are not part of our answer. Okay. Now, with the and statement, let's see, I think I'll erase this stuff. You can always back the video up if you need to see it again. But I need some room here. So let's look at the and statement. So we've got -2 less than or equal to x minus 2 less than or equal to 2. Okay, now here's the thing about solving one of these compound inequalities. When we had the or, it was already split into two different pieces and we just solved each one separately. Now with a standard equation, let's say x plus 4 equals 9. Now when I'm teaching beginning algebra, this is usually in Math 60 we see this, and sometimes in Math 70. I always tell people an equation has two sides. And anything that you do to one side, you should do to the other side. Right? That's how we solve equations. And there's our x equals 5. Okay. The thing about this compound statement using and, okay, is that there are no longer just two sides. Now there are three places in this inequality. And if we want to add 2 to get this x by itself, we're going to have to add it in 3 different places. So let's do that. Add 2 here, add 2 here, and add 2 here. And if we do that, we get the x in the middle. Here we get 4. Here we get 0. Okay? So these are the endpoints of our answer. X has to be less than or equal to 4, and at the same time, greater than or equal to 0. So, here's the 0, here's the 4. They both get colored in because they both have the equals to on there, and we're only interested in all the numbers between those two. And this is typical of what an AND statement will look at. Now, these are not the only possibilities for AND and OR. There are some other ways that these problems work out. They get pretty convoluted and somewhat difficult to understand. We're not going to cover those. This is what you'll see in the assignment. This is what you'll see on your test. Okay? If you're interested in those other problems, I'd be happy to talk with you about them, but we're not going to cover them in class. Okay, so there's problem 2, and we got it solved, and we graphed it on a number line, so we're all done with that. So let's pick our way through a couple more examples. Let's see here. Well, let's look at problem 4. And problem 4 is an AND problem. Okay? And you can tell that because it's written all together. It's two statements combined into one. And notice again, we've got those 3 places where we're going to have to do anything that we do in one of those places, we have to do in the other 2. All right? So, for starters, we're going to add 4 in all 3 places. So, those cancel out. That leaves us with 3x. Over here we have 18. Over here we have 12. Divide in 3 places by 3. And that says that our x should be between 4 and 6 to satisfy the original statement. And then we'll graph it on a number line. And there it is. X is less than 6, but greater than 4. And at the same time, greater than 4. All right. Let's see here. What else? Problem 8. Let's see here. -3 less than 5 minus 2x less than 1. Okay. Let's see. I was just talking about combining like terms for the Math 70 class. And that gave me an opportunity to point out that the sign for a term is always in front of it. And if there's no sign in front, that means there's a plus. The reason why I'm saying that is because if you want to get rid of this 5 right here, don't look to the sign that comes after the 5. Okay? This sign right here is attached to that 2x. The 5 is a positive 5. So if we want to do anything to that 5, by getting it out of the way so that we can get our x by itself, we're going to need to subtract 5 in all 3 places. So those cancel out. Don't lose the negative sign that's attached to the 2. We'll have -2x, -4 here, and -8 over here. And again, if you're not sure about adding and subtracting these positives and negatives, please check it out with your calculator. Okay? All right, let's see. What else? Now to get this x by itself, we need to divide by -2. So, remember to divide in 3 places by -2, and also, we're dividing by a negative number. That's going to flip these around. This will be 4, this will be 2, and this says our x should be between 2 and 4, greater than 2, and at the same time, less than 4. Okay. Let's see what else we've got here. Excuse me. All right. Let's look at one more of the AND statements. Problem 10, -4 less than or equal to -4 minus x less than or equal to -2, +2. Let's fix that. There we go. All right, so again, we want to get this -4 out of the way so that we can get the x by itself. That means we're going to need to add 4 in 3 different places. Those cancel out. This will be a -1x. We haven't done anything to flip these around, so they stay the way they are. This will be 6. That'll be 0. Okay, now to get this negative or -1 out of the way, we're going to divide in 3 different... Oh, excuse me, I almost sneezed. We're going to divide in 3 different places by -1. Now, because we're dividing by -1, again, that will flip this around, make that -6, greater than -6, less than or equal to 0. Okay, so that says all of our answers need to be between 0 and -6, and they get colored in because they are also equal to those values. And so there it is. X is less than or equal to 0, and at the same time, greater than or equal to -6. All right. Let's see here. All right, so that's it for the AND problems. Now let's take a look at some OR problems. Now these are typically stated separately, and in fact, if you write something all together with 2 of these inequalities, it is an AND statement. No matter what you think you're writing down, everybody else in the world interprets this as an AND statement. So please don't try to write these OR statements all together as one statement. So let's see here. 12. Oh, I did that as an example already. Okay, let's look at 14. So 14, 3t minus 5 less than or equal to -14, or 5t plus 5 greater than or equal to -5. All right, so here we're going to add 5 to both sides. 3t less than or equal to -9. And divide on both sides by 3, so we get t less than or equal to -3. Or, on this side, let's see, we'll subtract 5 on both sides, and then divide on both sides by +5, so we get t greater than or equal to -2. So there's our answer, and this will go off in either direction. In fact, the only numbers that don't satisfy either one of these is just all the numbers between -3 and -2. Everything greater than or equal to -2 satisfies this one, and everything less than or equal to -3 satisfies this one. So there's our answer. T less than or equal to -3 or greater than or equal to -2, and there it is going off in opposite directions. And that's typical of the OR statements. Your AND statements typically will look like that. Okay. Let's look at a couple more here. What else? Let's look at problem 18. Oh no, 16. 16, -2x minus 3 less than or equal to -1, or -2x minus 3 greater than or equal to 5. Okay, so here we'll add 3 to both sides, and then divide on both sides by -2. So that will flip around the inequality and leave us with a -1 here. Or add 3 to both sides there, and then divide by -2, x less than or equal to negative 4. Okay? And again, because we divided by negative 2, this flipped around, and that'll leave us with a solution. There's negative 1 and negative 4, our endpoints. So we want everything greater than or equal to negative 1, or everything less than or equal to negative 4. So there's our solution. It's just the numbers in the middle there that are not a solution for either one of those. Okay. Let's see what else we've got here. Let's do a fractions one, problem 20. Let's see, 3/4 x plus 3 greater than or equal to 6, or 3/5 x minus 3 less than or equal to negative 6. Okay, let's see here. So for starters here, we'll subtract 3 in both places. And then, again, you can divide by 3/4 if you're in the habit of doing that. I'm in the habit of multiplying by the reciprocal, and so that's how I usually get that x by itself. Let's see, same thing here, add 3 to both sides, or actually, that was subtracting 3. So here we'll add 3 to both sides, 3/5 x less than or equal to negative 3. And then again, you can divide by 3/5. I'm going to multiply by 5/3. And then we get x less than or equal to negative 5. And notice we didn't flip these around because in both cases we were multiplying by a positive number. And so our solution on the number line looks like x greater than or equal to 4. And then over here, x less than or equal to negative 5. And it has that typical or look to it. Okay? All right. The rest of these problems are just some and or problems mixed together. So I'm not going to go over any of those as examples. I think we've kind of touched on the major ideas for these problems. The next assignment, we'll talk about absolute value, what that means, how to solve equations involving absolute value, and then we'll also apply these ideas to that as well and see what happens when we have an absolute value with some inequalities in it. Because that's something that typically happens in statistics and in engineering. Frequently you have situations where you've got a tolerance for error, where your answer has to be between a range of values. But anyway, we'll talk about that more when we get to it. Until then, if you have any questions, please let me know.